Hello and welcome to another Orange Coast College mathematics video. In this video, we're going to learn to divide polynomials, also called polynomial long division. Now before we begin, I'm going to assume that you're comfortable adding and subtracting polynomials and that you can do some multiplication of polynomials as well. Now, dividing polynomials has some application in the future. If you take calculus especially, it can be really useful. But a lot of times you can simplify polynomials, or fractions involving polynomials by, factoring the numerator and the denominator and then canceling out any common factors. Polynomial long division can be used when the degree of the numerator is either the same or larger than the degree of the denominator. So before you try to divide two polynomials, if the degree of the denominator is larger, you have to stop. You can't do it. And just to remind ourselves, the degree is whatever the largest power of the variable is. So for instance, in this polynomial in the numerator here, this is a degree 2 polynomial because the largest power of the variable x is 2. In the denominator, this is a degree 1 polynomial because the largest power of x is 1. So in this case, we can do polynomial division. But if the degree of the numerator is smaller than the degree of the denominator, we would not be able to. We begin with the following simple example where we want to divide a polynomial here by a monomial, so a single term polynomial. So you could think of when the numerator is any polynomial and the denominator in a fraction is a monomial, so it has one term. Or the other way we can think of this is the dividend. So the numerator we can also call the dividend, and the denominator we can also call the divisor. Okay. So in this situation, it's a bit different from doing polynomial long division. When the denominator is simply a monomial, you can just rewrite this fraction as writing each term over the monomial. So 3x squared over x minus 2x over x plus 4 over x. And so now you can just cancel out any common factors within the numerator and the denominator. So we have a common factor of x here. So this is x to the first, so it becomes a 1. Okay, we can cancel out this x here, so which gives us 2 times 1. And then the last term, we cannot do anything. So this ends up being 3x minus 2 plus 4 over x. And we kind of have what is a sort of all of our examples will generally end up as, which is the quotient here. And then this 4 is actually what we're going to see is the remainder. And it's written over the divisor, which is the denominator. Okay, so in this one, we've sort of just simplified this fraction to end up like this. But you'll see we'll end up with a very common, we'll end up with a situation that looks a lot like this in our next examples, where we have the quotient plus the remainder over the divisor. But we're going to get back into doing it like long division in the next example. Here we have our second example where we'll need to use more traditional polynomial long division. Since we have our denominator or divisor, if we think of this as a quotient or a division problem, now has 2 terms. Okay, so we cannot just divide each term by that. It won't work out. So we rewrite our division in sort of like we used to do polynomial, like we do long division with numbers. So it's y minus 1, and then under the box goes y cubed plus 4y squared minus 3y minus 2. Now we want to make sure before we get going here that our dividend, so the numerator, all of these terms are in descending order of power of the variable. So it's y cubed, and then the next one is y squared, then y to the first, and then the constant term, which would be y to the 0 power. We also want to make sure any missing powers are represented. So if we're missing a power, we could just include it with a coefficient of 0. We'll see that in a future example, but here we're all good. So we have start with y cubed, and each power is in there. We want the same thing for the divisor as well. And now when you're doing polynomial long division, the thing to just remember is you always want to match the first term on the left in the divisor with the first term here. And you want to say, what do we multiply this by to get the first term over here? So I multiply y by y squared, and that will give me y cubed, which means the first term in our quotient will be y squared. And now multiply each term by y squared and write them underneath the dividend. So y squared times y is y cubed. And then y squared times -1 is negative y squared. Okay. And then just like we did with long division with numbers, we're actually subtracting here. You're going to take this and subtract it from this. So y cubed minus y cubed is 0. 4y squared minus negative y squared will be 5y squared. And then since we have two terms here, we need two terms here, so we just drop down the next one. So we drop down the negative 3y. Okay, and then we repeat. Again, now you have the first term here, and you compare it to the first term here. And you say, what do we multiply this by to get 5y squared? Well, if I multiplied y by 5y, that would give me 5y squared. So our next term is going to be positive 5y. Okay, so 5y times y is 5y squared. And 5y times -1 is negative 5y. Okay, and now again, we subtract. And if we do that, 5y squared minus 5y squared is 0. Negative 3y minus negative 5y will be positive 2y, right? Negative 3 plus 5. And again, two terms, so we have to drop down our remaining final term here. And again, compare the y to the 2y. I multiply y by 2. That would give me 2y. I want to make that match. So our last term here is going to be a positive 2. Okay, so 2 times y is 2y. And then 2 times -1 is -2. And so if we subtract 2y minus 2 minus 2y minus 2, we just get 0. So down here, whatever we end up with at the end, when we run out of terms, that would be our remainder. But our remainder is now 0. So what that means is that this quotient is just y squared plus 5y plus 2. So it means you can simplify this fraction of polynomials as its quotient, y squared plus 5y plus 2. And that's it. Normally, like I said in the last problem, you'll have plus a remainder. If you have a remainder, it'll be plus the remainder over the divisor. We'll see that in a minute. Okay, here's our final example. Now, one thing I haven't mentioned up until now is it can be very helpful if you can factor, if you see how to factor the numerator and denominator, it can be useful to cancel out any common factors between the numerator and denominator. Now, it doesn't apply here, but I thought I should mention it. All right, so our first step is going to be to rewrite this in sort of the long division form. So we have 2x plus 4. Now, I mentioned this earlier, but you'll notice we're missing the cubic terms, x cubed, missing the x to the first power terms. Now, when we write a polynomial, we don't necessarily have to write out those terms, right? Like we don't need to have an x cubed term to write the polynomial. But when we're doing the long division, we need those terms. It'd be like if you wanted to do long division with numbers, and if you had a 0 in one of the digits, suppose I had a 0 in the hundredths place, if I just skipped that place, right, that wouldn't work for long division. So it wouldn't work for us now. So what we're going to do is we're going to include those terms by giving them coefficients of 0. So we have 6x to the fourth. Then we're going to have plus 0x cubed, and then minus 20x squared, and then plus 0x, and then minus 19. Okay, and now we just do what we've been doing. So what do we multiply 2x by to get 6x to the fourth? We would multiply it by 3x cubed. Okay, and now we multiply each term in this divisor by 3x cubed, and we get 6x to the fourth, and we get plus 12x cubed. And you see now, right, we line up x cubed here and here. So if we didn't have this term, this would be underneath the x squared term, which we cannot combine those terms together. So this works out nicely for us. And now we subtract. And if we do that, the 6x to the fourth cancels out. And we have 0x cubed minus 12x cubed. So that gives us negative 12x cubed. And then we drop down the next term. Okay. And so to multiply, what do we need to multiply 2x by to get negative 12x cubed, we would multiply 2x by negative 6x squared. So we want to have our next term in the quotient is negative 6x squared. We multiply both terms in the divisor by that. We will get negative 12x cubed, and we will get negative 24x squared. Okay, now we subtract. The negative 12x cubes cancel out, and we have negative 20x squared minus negative 24x squared. That will give us positive 4x squared. And then we need to drop down the next term, which is 0x. Okay, and again, you'll notice we multiply 2x by 2x to get 4x squared. So our next term in the quotient is 2x. And then we multiply 2x by both terms. We get down here 4x squared plus 8x. Okay, and then we subtract. And again, by putting the 0x in that place and holding that place, now our terms line up so that they have the same powers, right? That's very helpful. So we end up here, 4x squared minus 4x squared is 0. We end up with negative 8x. We drop down our final term, negative 19. We multiply, what do we multiply 2x by to get negative 8x? We multiply 2x by negative 4. So the last, it's going to be the last term in our quotient is negative 4. So if we do that now, we get negative 8x minus 16. And so our remainder here is kind of ran out of space here, but we're going to get the 8x, negative 8x minus 8x is 0. And then negative 19 minus negative 16 will give us positive 3. I ran out of space here, so I'll just write it off to the side. And so now the degree of this term, right? This is a constant. Constants are degree 0. It's now smaller than the degree of this term. And so we stop. Once you get the degree here is smaller than the degree here, we must stop. So this is our remainder, okay? And so this is our quotient up here. This is our remainder. We can rewrite this if we wanted to. This is going to be helpful for different applications, especially in calculus, be able to rewrite a quotient like this as the quotient plus the remainder over the divisor. It will look like this. It'll be 3x cubed minus 6x squared plus 2x minus 4, and then finally plus 3 over 2x plus 4. And that's it for polynomial long division. Now, these problems can be tricky because they involve a lot of steps. So my suggestion is go slow at first, okay? Try to look out for some of the pitfalls that we mentioned in this video, and just take your time. Be careful, right? If you do that, you'll pick it up in no time. Until next time, have fun.